The focus of today's lesson is going to be on solving conditional probability problems with the strategy being drawing a tree diagram. So for the opening example here, tennis great Roger Federer made 63% of his serves in the 2011 season. When Federer made his first serve, he won 78% of his points. When Federer missed his first serve and had to serve again, he won only 57% of the points. Suppose we randomly choose a point on which Federer served. And the first thing it's asking us to do is to draw a tree diagram. And then after we draw a tree diagram, they are going to ask us some probability questions. All right, so the first branch of the curve here is going to be, did he make his first serve or not? Not first branch of the curve, first branch of the tree, rather. So those are the two possibilities for step one. He either made a serve or he did not. And according to the problem up here, he made the serve 63% of the time. And for these, it's typically best to use decimals. Well, if he made a serve 63% of the time, it means he missed his serve 37% of the time. Okay, now we're going to branch from here. Did he win the point or did he lose the point? So the possibilities are he's made his first serve, he wins point. Made his first serve, lose the point. Didn't make his first serve, still wins the point. Did not make his first serve, loses the point. Okay, now the probabilities are when Federer makes his first serve, so we're in this part of the branch here, he won 78% of the points. So it's going to be 0.78. Well, if that's 0.78, that means this must be 0.22. Because after he makes his first serve, he either wins or loses. So if that's 0.78, subtract from 1 to get that. Okay, when Federer missed his first serve, so now we're down here, and he had to serve again, he won only 57% of the points. So it's 0.57. That's 0.57. This makes 0.43. Now what we're going to do is we are going to multiply the 0.63 times the 0.78 and put that there. So if he makes the first serve and he wins a point, that has a probability of 0.4914. 0.63 times 0.22 gives us the probability of 1.1386 that he made the first serve and lost the point. Same thing here, 0.37 times 0.57, 0.2109. 0.37 times 0.43, 0.1591. Now, one check that we can give this to make sure things seem to be set up properly is the fact of all of these guys have to add to 1. This is every possibility of what could occur. He made the first serve and wins. Makes the first serve and loses. Doesn't make the first serve and wins. Does not make the first serve and loses. That's everything that can happen in this scenario. That means this has to add up to 1. Okay. Now on to the questions are asking us probability-wise. Slide this up. Make sure this can be seen. All right, so that looks pretty good. Let me shrink this down a little bit. All right, so the first question here, when Federer is serving, what is the probability that he wins the point? Okay, well, winning the point happens here, and it happens here. So the answer to this question right here is going to be the sum of those two guys. It's going to be 0.4914 plus 0.2109, and it turns out to be 0.7023. Second thing here, if Federer wins the point, what is the probability that he missed the first serve? So we have a conditional probability going on here. Let me get another piece of paper with this so there's room to write this out. So translating that into the symbols, if Federer wins the point, what's the probability that he missed the first serve? So the probability that he missed first serve given that he wins the point. All right, so from the formula, we know that the top of the fraction is going to be the probability that he missed and wins, and then divided by wins. And that's just straightforward directly from the formula. All right, so he missed and wins. Okay, missed and wins, we've already calculated that. That's 0.2109. Probability of wins, we just calculated that up here. That's the 0.7023. Divide those out, and 4 decimal places with these guys usually is a nice safe round number to work with. For the table here, or the tree rather, you definitely want 4 places. For a final answer, you don't necessarily need all 4. That might be overkill, but it's safer to just stick with the 4 if you did 4 up there. All right, last one for this. If Federer doesn't win the point, what is the probability that he made his first serve? So probability that he made first serve given he didn't win the point. So that takes that question, which is kind of written in everyday language, translates that into the format that matches the way we learn the formula. And from that, we know it's a probability of made and no win over probability of no win. Okay, well, any of the ands we already figured out. They're going to come from these numbers at the end. So let me slide that up. There we go. So made and didn't win. Made, didn't win or lose is the same thing in this, 0.1386. The probability of not winning on the bottom. A couple different options here. We've already figured out the probability of winning. That's 0.7023. So we can just subtract that from 1. Or we could add these two guys here. The not winning is a combination of these two numbers right there. And that turns out to be about 0.4656. All right, in terms of the big picture of statistics, as you guys know, we are working in chapters 5 and 6, which are the 2 chapters in the book that focus primarily on probability skills. Probability is an inherent part of the entire course, but these are the 2 chapters that directly address it as its own topic. Okay, within the world of probability, these types of questions are considered pretty important. They're pretty much guaranteed to be on the AP exam when you get there in a minute. All right, that being said, get through 1 or 2 more examples. Video sharing sites like YouTube are popular destinations on the internet. A study was done on adult internet users aged 18 and over. 27% of adult internet users are 18 to 29, 45% are 30 to 49, the remaining 28 are 50 and older. The study finds that 70% of internet users aged 18 to 29 have visited a video sharing site, along with 51% of those 30 to 49 and 26% of those 50 and older. Suppose we select an adult internet user at random, and the first thing it's asking us to do is draw a tree diagram to represent the situation. Right. Even if they didn't specifically say on a free response question on the AP to draw a tree diagram, for these types of problems, it's assumed that you should, that would be considered part of showing the work in order to answer these questions. So even if that statement wasn't there and they just started asking you these things, it would be expected that you draw that tree diagram. All right, this is slightly different from the first one because our initial tree has 3 branches. It's what age group do you fit into? Didn't really line up very well, did it? I think that a little more symmetric. There we go. So the 3 age groups are 18 to 29, 30 to 49, and then 50 plus. Then from there, do you YouTube or not? And I'm just going to put YT for YouTube. Now we'll fill in the corresponding percentages. Okay, as far as the age group here, 27% of adult internet users are 18 to 29. So that's 0.27. 45%, and then 28% here. These guys should add up to 1. So you can give that a quick check, add them up to make sure that everything seems right, and they are. All right, now we got to do the second wave of the branches here. So we need to go to the study finds that 70% of the internet users 18 to 29 have visited a video sharing site. So for the 18 to 29 branch, 70% of them are YouTubers. That means 30% are not. Okay, for the 30 to 49 group, what do we have here? 51% of the 30 to 49 group, YouTube. That means 49% do not. And then lastly, for the 50 plus crowd, what is our number for that? 26%, 50 and older. So 26% YouTube, that means 74% do not. Okay. After we get this part of the tree done, we're going to multiply that times this gives us the and. That times this gives us the and. That times this gives us the and, etc. I'll fill in these numbers. 189, 181, 2295. 2205, 0728, 2072. So, for example, this 0.2295 represents people that are age 30 to 49 and use YouTube. That's that category right there. All right. First probability question they're asking us. Find the probability that this person visited a video sharing site. Well, the people that visited video sharing sites are the YouTubers, combination of that, in that. So it's going to be 0.189 plus 0.2295 plus 0.0728 and then 0.4913. All right, now for these numbers here on the tree, you definitely want to be going at least to 4 decimal places. Sometimes you may need more if they're really, really small probabilities, but 4 usually is the safe way to go. The final answer, safe to stick with the 4, but you could round that down a little bit if you wanted to in terms of less decimal places. All right, next question. Given that the person has visited a video sharing site, what is the probability that he or she is aged 18 to 29? So, let me get another piece of paper here, I'm sorry. So translating that into the notation, that's the probability you're 18 to 29, given that you're a YouTuber. So that means it's the probability of 18 to 29 and you're a YouTuber divided by the probability of being a YouTuber. Okay, that 18 to 29 and YouTuber, 18 to 29 and YouTuber, that's 0.189. We can extract that number from the table. The probability of being a YouTuber, we've already figured that out. That was the part 1 of that question there, 0.4913. Divide that out. If we stick to the 4 decimal places, that's about 0.3847. All right, last one from this section. Given that a person has not visited a video sharing site, find the probability that he or she is aged over 50. So that's the probability that you're 50 plus, given you're not a YouTuber. So the formula is the and of those two things up top divided by that second one plug in those numbers. So the probability of being 50 plus and not a YouTuber, slide that down, 50 plus, not a YouTuber, that's 0.2072. And then the probability of not being a YouTuber, we can add up the 0.81, 0.2205, 0.2072, or just do 1 minus that. It'll take us to the same number in the end. And I do not have an answer written down on my answer key. Let's check that real quick. See what that turns out to be. 0.2072 divided by 1 minus 0.4913. And that's 0.4073 for decimal places. Okay, this question here will also flesh out a little bit more in terms of what's expected when you're showing the work. Naked answers or bald answers, those are two popular, not necessarily flattering phrases to describe answers with no work, no justification. If it's an AP free response question and all you have is that answer, you are pretty much guaranteed to not get full credit. Depending on the strictness of the rubric, it's possibility you get no credit whatsoever at all. Okay, to be on the safe side, what you should be showing is translate the question into probability notation. From there, write the blank formula. From there, plug in the numbers. From there, show your final work. If you have all these 3 things in place, you are pretty much guaranteed to get the full credit, checking all the boxes. There's nothing that can go wrong. One or more of those things is missing, you're running the risk of not necessarily getting the full credit. Just the final answer is pretty much unacceptable in almost every AP free response. If that's the habit you're in, you need to start breaking that habit. All right. One more problem, or one more scenario. All right. Many women choose to have annual mammograms to screen for breast cancer after age 40. A mammogram is not foolproof. Sometimes this test suggests that a woman has breast cancer when she really doesn't. Okay, that's known as a false positive. False referring to the fact that the test came out wrong. Positive meaning it's saying you have something that you don't. Other times the test says that a woman doesn't have breast cancer when she actually does. That's a false negative. False referring to the fact of the test was wrong. Negative in terms of it said that you didn't have something. Suppose we have the following information about breast cancer and mammograms in a particular region. 1% of the women in the region aged 40 and over have breast cancer. 4 women who have breast cancer, the probability of a negative mammogram is 0.03. For women who don't have breast cancer, the probability of a positive mammogram is 0.06. Okay, as a side note, medical scenarios are very popular in the AP statistics world. They tend to be the topic of a lot of different word problems, a lot of different free response questions. So being familiar with the terms false positive, false negative, things like that it's a good skill to have because it's a common scenario. The more comfortable you are reading things like that, the easier the problems become. All right, in the interest of time, I'm going to jump right to a pre-made answer here. So let me see what I can do. We need to fit on one screen here. Let's do this and this. That all fit? All right, that works out pretty well. All right, so it says right here, 1% of women in this region aged 40 or over have breast cancer. So the first branch of the tree is going to be you have breast cancer or you don't. 0.01, 0.99. Okay, 4 women who have breast cancer, so we're on this part of the tree, the probability of a negative mammogram is 0.03. So negative mammogram means that the test came out negative. So if it's a negative possibility for the test, 0.03 there, that has to be 0.97. Okay, now on to the bottom part. For women who don't have breast cancer, we're on this part of the tree, the probability of a positive mammogram, test says positive, is 0.06. So that's 0.0, I'm sorry, get to that in a little bit. If that's 0.06, that has to be 0.94. All right, once we get this part of the tree done, that times this goes here, that times this goes here, that times this goes here, that times this goes here. We didn't do the check or talk about it last problem, but you can add all these up, make sure they add to 1. And in this case, they do. All right, let's see what they're asking us for. A randomly selected woman aged 40 or over from this region tests positive for breast cancer in a mammogram. Find her probability she actually has breast cancer. So the probability that she has breast cancer given that she tested positive. So the top of the fraction is going to be the and of these two things. Breast cancer and you test positive. Breast cancer and test positive, 0.0097. Divided by the probability that she tests positive. The probability of testing positive is the combination of that and that. Those are the two scenarios where people are testing positive. Do your order of operations, gets to be a probability of roughly about 14%. All right, last problem. A randomly selected woman aged 40 or over from this region tests negative for breast cancer in a mammogram. Find a probability that she actually does not have breast cancer. So the probability that you don't have breast cancer given that she tested negative. So the top of the fraction is the and of those two things. So no cancer and test negative no cancer, test negative, that's 0.9036. Divided by the probability of the second thing. Now, we've already figured out the probability of testing positive up there. We can just subtract from 1, or we can add up these two categories of the testing negative. And that turns out to be almost 100%. 99.97% chance of that happening. All right, that is it for today.